Trigonometry, there are a couple of definitions that we need to know when we are trying to work out some word problems, and that's angles of elevation and depression. So, first of all, angles of elevation. Either one of these definitions come from us looking straight across or from the horizontal. So angles of elevation, we are down at the bottom here. So you can see we are looking straight across at the horizontal. And what is happening is there is something up here at the top, whether that be a plane, whether it be a tower, whether it be a cliff that we're looking to the top of, but we are looking. So the horizontal is here, and we are looking up at whatever it is up top here. So the angle of elevation is in between those two sides of our triangle. So again, we are looking up at something, and the angle between looking straight ahead and looking up, and remember, elevation just simply means up. Well, if we are talking about angles of depression, remember, depression means down. So again, it is still looking from our horizontal, but now we are up top of the triangle. We're up here. So our horizontal is looking this way. So now, whether this is a boat, whether we're in a tower looking at a forest fire, we are looking down at our object down here. So the angle formed between our horizontal and whatever we're looking down at is our angle of depression. So notice though, this is outside of our triangle, but if we're looking at our horizontal, where our horizontal is also down at the bottom. So we have parallel lines here. And parallel line theorem tells us that with our Z pattern, remember our Z pattern, that this angle down here has to be the same as this angle up here. Now, if we're creating a diagram, we do need to show that we first of all have our angle as our angle of depression in here, but then we can also show that it's the same angle down here. Okay, so taking a look at some questions here. Example number 1, our angle of depression, our angle of elevation at the top of the building is 33 degrees. And the angle of elevation to the tower on top of that building is 38 degrees. So these angles are measured from a point 200 meters from the base of the building. We want to figure out what is the height of the tower. So we're looking for the height of both diagrams or both items. So first of all, anytime we have a question like this, we are going to draw our diagram. So we're going to have our building, and we're going to have our tower on top of that building. So we're going to have our tower, and we're going to have our building. And we're measuring our angle of elevation from a point 200 meters away from the base of the building. So we're measuring our angles from here, 200 meters away from the building. Now, we have actually two different triangles here. We have one to the tower and one to the top of the building. So we have to the top of the building is 33 degrees. And this whole thing to the top of the tower is 38 degrees. Well, if we want to know just the height of the tower, so X is just this little length in here. Well, first of all, we have to find the length of the building or the height of the building, and we also have to find the height of the entire thing. So what we're going to figure out, we've got to figure out the height of the tower is the height of both minus the height of the building. So we're going to use both of our triangles here. We have a smaller one in here, and we have a bigger one, the entire triangle, the big triangle. So first of all, we are going to find our big triangle with the tower. So we have our 38 degrees. We know that from our angles over here, we're working with opposite, and we have our adjacent. So we're going to start with tan of our 38 degree triangle is, and let's use x for this one, and we're going to say let x represent height of both. So we're going to define what it is that we're looking for. So we have our 38 degree angle is the height of the entire thing over 200. So 200 times tan 38 is equal to x. When we put that into our calculators, we see that x is equal to 156.26. And notice that we're keeping an extra decimal place in there because we don't want to round. Actually, we're keeping to the nearest thousandth, so we make sure we have 2 decimal places. Now, the second part is we want to know how high the building is. So we're going to let y represent height of the building. Notice we need to use a different variable, and this time our angle of elevation is 33 degrees equals y over 200. Taking our 200 to the other side and putting into our calculators 200 times tan 33, we get 129.88. So now we have our two numbers, and we are going to calculate the height of the tower by taking 156.26, subtracting 129.88, and we get 26.38. So that is our final answer. That's what we were asked for. We double checked that in the question, and the tower is 26.38 meters tall. Okay. Example number, and sorry, that should be example number 2. From the top of a cliff 120 meters above the water, the angle of depression of a boat on the water is 18 degrees. How far is the boat from the base of the cliff to the nearest thousandth? So again, starting with our diagram, and here we just have one triangle. And so our water is down here. Our cliff is over here. And we have our boat on the water over here. And we know our cliff is 120 meters tall. Our angle of depression, remember our angle of depression is from the top of the cliff, the horizontal, looking down. So our angle of depression is 18 degrees. And we must show that we know that that's where the angle of depression is. But we also know that the one down here has to also be 18 degrees because they are parallel. So looking at our angle of 18 degrees, We know how tall our cliff is, which is our opposite, and we're looking for our adjacent. So again, using a variable, we're going to let x represent distance from the boat to the cliff, which is what we need to find. So we know that tan of an 18-degree angle is going to be equal to our opposite, which is 120, over our adjacent, which is x. Because x is on the bottom, we have to take it to the other side. At the same time, we can bring our tan 18 over and divide. And when we do this, when we put this into our calculator, 120 divided by tan 18 and equals, we know that we want to go to the nearest thousandth. So we're going to keep 2 decimal places. We get 369.32, and that's exactly what we have for our solution. We can state our therefore, the boat is 369.32 meters from the cliff. Okay, so just a couple of new definitions or review of definitions, angles of depression and elevation, and some questions